2 point D graphing characteristics. So a lot of these characteristics are things you've heard or seen before. But we're just kind of going to put it all together. So we're going to start with some definitions, some things to have in mind. So whenever we determine a piece of a function is positive, we are referring to whenever it's above the x-axis. So whenever the y value is greater than 0, that's what we would determine or call a positive function. Increasing functions, this is referring more to the slope. So this would be like as your x value increases, so does y. So increasing refers to the positive slope. So an increasing refers to the slope. Positive just refers to its location in relation to the x-axis, whether it's above or below. Concave up, this is probably new, but these are functions or parts of functions that curve up, kind of like a bowl in a way. So like an upward-facing parabola, we would call that whole function concave up. The absolute max is the highest point on the graph. A relative max is a point higher than surrounding points. So an absolute max means there's no point above it. A relative max is like if there's a peak, but then it continues to increase later on. So like if we have a function like this would be a relative max because it's not the absolute maximum because the function does go higher, but it's higher than the surrounding points. Okay. On the other side, kind of the opposites. A negative would be referring to anything below the x-axis. Decreasing would be like a negative slope. So as x increases, y decreases. So think negative slope. Concave down would be something that curves down. I don't know, like a frown maybe. An absolute minimum, well, that's the lowest point on the graph. And a relative minimum would be a point lower than its surrounding points. So I'm sure you can see how it would be valuable to first find absolute maxima and minima before finding relative maxima and minima. So these are the things we're going to be looking for. So we're going to do a couple of problems where we're looking at graphs and determining these characteristics. So when we are describing these characteristics, we always want to think in terms of x values if it's talking about some sort of a range. So like to start with these positive values. So positive means above the x-axis. And we'll just go from left to right. So here it's at 0, negative, negative, negative. At negative 2, it shifts over to positive up until negative 1. So our first range, remember, always think about it in terms of the x-axis or our interval in terms of the x-axis is from negative 2 to 1. Sorry, negative 2 to negative 1. And remember how we talk about with domain and range where you have like open parentheses versus closed parentheses versus brackets. Open meaning not including, bracket meaning including. In this case, negative 2 is not technically positive, it's 0. So we wouldn't include it, but we'd include very close. Same idea over here. And as we continue, negative, 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 up until we get to 0. Then we go more positive. Up until 1, we have an open circle. But if you notice up here, it does happen to stay positive. So all the way up until 1, we have an open circle, but then a closed circle here, still positive. So we're still positive, still positive, still positive up until here, which is, I don't know, 1.7, we'll call that. And it wouldn't be including that value because it's right at 0. So then we're negative, we're negative, we're negative, up until, boom, right at 2. this is where our bracket comes in because we do want to include that point at 2 because that point at an x value of 2 is positive. And then we're positive, we're positive, we're positive, we're positive until here, but at 2.5, and we hit 0. We're negative, we're negative, we're negative, we're positive here at 3.5, all the way up until 4.5. So notice positive just referring to above the x-axis. So that would be here, 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 and here. So negative, we can kind of assume is just the rest, but we'll be negative here from -3 to 2. And again, not including, because it does start at 0 on both ends. Then over here, we're negative from 1 all the way up to 0. And this would be including 1, because the 1 does start negative 1, all the way up to 0, not including. And we're positive up until here. This is 1.7 we called. Up until, but not including 2, because it's an open circle. And then we're negative again here from 2.5 to 3.5, and then from 4.5 to 5. And we're going to say it ends there. So we would include that because it does end negative. Okay. So positive referring to above the x-axis, negative referring to below it. Increasing refers to slope. So as we look here, we're decreasing from -3 to about 2.5, but then when we hit 2.5, we're increasing all the way up until we hit that top point. So we are increasing from -2.5, we'll call that. And we do use a parenthesis here, not a bracket. So technically, right when you get to that minimum point, there's for a split second, it switches from decreasing to increasing where it has no slope at all. It just has a straight line. It has a slope of 0. So right at -2.5, it doesn't have an increasing slope. But from -2.5 all the way up to -1.5, and then it stops right where it switches. It has that 0 slope. Okay. For our next one here, we've got from -1 to 0, we are increasing. And that -1 is a sharp point. It's a closed point, so it does include, right at -1, it is increasing. All the way up to 0, and then keep going, keep going, keep going, up to 1, but not including it, because it is an open circle. Then we are decreasing here from 1 to 2, decreasing still from 2 to 3, and then from 3 to 4, we are increasing there. Again, we should have parentheses there because it's switching from decreasing to increasing or increasing to decreasing where we have a slope of 0 there. For decreasing, so from here, -3 to 2.5, and it does start decreasing, so we're going to assume that we're going to give that a bracket, but then at 2.5 it switches from decreasing to increasing. Over here we go from -1.5 to 1, and not including it because it is an open circle. We're increasing. Right at 1, we're in the process of decreasing, so it'd be a closed bracket because we want to include that point. All the way up until 2. But then if we continue up to 2 and at 2, it does look like we're still decreasing there. So we're still decreasing from 1 all the way up until 3, but not including, and then from 4, not including, to 5. That one's a little up in the air. I'm not sure if it levels off at 0 or not. So if you use a bracket or parenthesis, I'll leave that up to you. I'll just put them both there. Okay. Next we have concave up. So that refers to anything with a U shape. So again, this is in terms of an interval, x values. So from -3, we are up, we are up, we are up. And then there's some point where this is shifting. from up to down. So I would say it looks like it starts to make that shift right at 2 at this x-intercept. So I would say it's from -3 to 2. And we would include that -3 because it is facing down. From -3 to 2, that's where it switches from concave up to down. So just like with increasing and decreasing, there's a point where it switches from decreasing to increasing or vice versa. Same thing here. There's a point where it switches from concave up to down where it is neither. So I'm just going to say that's at that point of 2. So then if we wanted to write concave down, or sorry, -2, it'd be from -2 then to 1, -1. Straight lines don't have concavity. It only refers to curvature. So from -1 all the way to 1, there's no concavity there. There's no curve happening. Over here, though, there is a slight curve, it looks like, on this line here. So from 1 to 2, it looks like it's slightly going down. So from 1 up to 2. And then still, though, at 2, down to here, maybe at 2.5, it looks like it still is pointing down. So I'm going to say it goes all the way to 2.5. And then from 2.5 to 3.5, we are concave up because it has a U shape. From 3.5 to 4.5, we are concave down because it has a hat shape. And from 4.5 into 5, we are concave up. And probably including that 5. Okay. Next we have our absolute minimum, absolute max. So absolute minimum, maximum is the absolute highest point. So as we look at this, we do have an absolute highest point here at 1, 2. So we do write these as points. So these are all written as points. These are all written as intervals. An absolute minimum is the lowest point. Absolute means it has to be the lowest. There can only be one. In this case, we have 4 points at a y value of -1, so there would be none. Relative max are points that are higher than their surrounding points. So you look for like peaks. So like over here, we have this kind of peak here at -1.51. So we'd call that a relative max. In addition, we have another peak here at 2, 1. So it is higher than the points that are surrounding it, that are close to it. So we'd call that a relative max, as well as here at 4, 1. You'll notice I did not include 1, 2. The absolute max is not a relative max. The absolute max cannot be a relative max. Same would go for absolute min if we had one. For absolute minima, we look for low points. So right here we have one at -2.5, -1. We have one here at -1, -1. This point here is not a relative min because it's not technically a point. It's an open circle. And in addition, the points surrounding it, so to the left and right, they are, it is the lowest, but this isn't technically a point, so we can't really describe it as a relative min. Whereas we can describe this one because it is an actual point at 3, -1, as well as this one here at 5, -1. In regards to this point here at this open hole, so you can't say 2, -1 because it's not technically a point. I suppose if you wanted to kind of represent it, you could say like 1.9 repeating, so really close. And -0.9 repeating, so really close. You could maybe call a relative min, but since we can't actually quantify or define the point that's closest to this because it's infinitely close, we usually don't really talk about relative mins if they pertain to open circles, only closed, only real points. Okay. All right, let's do one together again. As you're looking at this, if you want to work ahead of me, by all means, go for it. I'm going to go fast through it, and then I'll let you try one on your own. So here, Positive is anything above the x-axis. So I'm going to do positive and negative together. So from, let's make these lines. So from negative infinity, it looks like, up to about, I don't know, negative 6.3. It's negative, and then it switches to positive, stays positive up until negative 3.1-ish, then switches back negative up to negative 2. Then at negative 2, we have a closed circle, so I'll use a bracket. It stays positive up until 2. And then at 2, close bracket, it stays negative up to about 6.3. And then at 6.3, it goes increasing forever. So 6.3 to infinity. So positive and negative. Increasing and decreasing, so it's increasing, it's going up and up and up from negative infinity up until about negative 5, we'll call it. Then from negative 5 to negative 2, it is decreasing, but it's still decreasing through all the way to 2. And still decreasing all the way to about 4, so negative 5 to 4 would apply for decreasing here. And then it increases from 4 up to infinity. Concave up. So it looks to be concave up, I would say. It starts concave up, so from negative infinity up until about 6, it looks like it shifts to concave down, and then it stays concave down till, I don't know, negative 3.5-ish, and then it shifts back to concave up for just a slight moment from negative 3.5 to negative 2. And this is a straight line, so it's not concave down or concave up. But then this last piece here, from 2 including, all the way to infinity, is all concave up. Okay. Absolute max. So as I look at this function, it is going up forever on the right, so we can't have an absolute max because it's approaching infinity. In terms of an absolute min, it looks like down here it's going down forever. If that's the case, then we don't have an absolute min. If it were to level off, it is a little hard to tell, then this point would be our absolute min. Furthermore, relative max. So we do have a couple. So we have this high point here at negative 5, 1. And we have this high point here at negative 2, 3. And that's it. We don't call like this a high point or anything because it's going forever. Relative mins, we have this one here, I see, at 4, negative 6. Beyond that, open circles can't be relative mins. This wouldn't be one because it's lower to the right, so we really just have one. Okay. All right, last one here. I want you to try, come up with all these characteristics on your own. Pause the video, and then we'll come back and talk about it. Okay, we're back. So it's positive from, this is the x-axis here, from negative 4.5 up to, but not including 2. So that is an open circle, so there's nothing there. And then from 2, or sorry, that's not 2, that's 0, because the x value we always focus on. From 0 up to about 0.5, it stays positive. Then it switches to negative from 0.5 to 1. Then we have a positive value here at 1. And it stays positive up until 3. And this one's at 0, so it's not technically positive. We leave it open. And then it's still at 0 at 3, but stays positive to, does that go on? Oh no, that's not a line there. So it just stops there. Okay. It is increasing here from negative 4.5 up to, it looks like, about 2. It does start increasing. Then it starts to decrease from negative 2 to negative 1, and then goes back to increasing from negative 1 to 0. Stops there. From 0 to negative 1, it's increasing, not decreasing, not including either points. Then from, sorry, that's just 1, my bad. From 1 up until 2, it's increasing. From 2 to 3, it is decreasing. Concave up and down, so it looks to be concave down from negative 4 all the way to maybe here-ish. So it starts concave down at negative 4.5, and then up until negative 1.5, it seems to switch to concave up and stay that way until it gets to 0. And at 0, it seems to flip to concave down till about here-ish. So from 0 to about 0.5, then it switches to concave up, it seems, from 0.5 to 1. Then from 1 to 3, it's definitely concave down, and it is including that point. Lastly, our absolute maximum, so our highest point, is this one right here. So this point, I know it doesn't look like an absolute max, but this is an open circle, so there does not exist a point here. This actually is the highest point at 1, 2. Absolute min. So we could potentially classify this 1, negative 1 as an absolute min, but we can't in this case because it's an open circle. So there actually is none. If it doesn't approach an exact point, we don't call there an absolute min. Relative maxes. So high points. We have one here, I see, at 2, 1. In addition, I would say this point probably here is a relative max at negative 2, 1.5. So there definitely is a relative max somewhere around here, a high point there. Relative min, so we have this point on the end here at negative 4.5, negative 0.5. In addition, right, let's see, where else do we have relative mins? We have one right here at negative 1, 1, and we also have one here at 3, 0. And that's it.